While Chris plugs up his laptop, I'd like to, seeing as Chris and I have known each other for many years and we're colleagues at the BBC, I'd like to take this opportunity to poke some fun at Chris, actually. It's a big time in Chris's life at the moment. He is obviously he's been leading the BBC's contribution to the ORPHEUS project, and it's the end of a piece of work that's lasted 2.5 years. The second thing, he's teetering on the verge of becoming a father for the first time within the month, so that's really exciting. But actually, the big gig is he can now put these initials in front of his name. He's just got his doctorate. So, Chris, well done.
Thank you.
But for now, you're going to tell us a bit about how you can use these tool sets and make some content, I guess.
Yes.
So, Chris, over to you.
So today I'm going to talk about a live end-to-end object-based production we did as part of the ORPHEUS project called the Mermaid's Tears, which has been mentioned a number of times today. I'm going to talk a bit about why the BBC is interested in creating object-based content, talk a bit about how we produced this piece, and take you behind the scenes to see some of the technology we used to achieve that. So there's kind of 4 main reasons we're really interested in object-based audio. The first is that it allows us to deliver an immersive experience to the audience, which we're starting to see a lot of demand for, especially with related technologies like VR starting to appear. There wants to be an audio equivalence. And object-based audio allows us to do that while targeting multiple formats, so like binaural and speaker outputs simultaneously without having to create individual versions. The second reason is we're interested in trying to make the BBC a more personal experience. There's an initiative called My BBC, where we get people to sign in so we know what they're listening to, what they're watching, and so we can start learning about their preferences and use that as part of the experience and part of the production. It allows us to hand over some level of interaction to the audience, still within the realms of control of production, so we're not handing full control to everyone, but it allows the producers to be a bit more creative about what the sorts of experiences they can put together and deliver to the audience. And finally, one thing that's very important to us is having a level of accessibility so that all these programs are accessible to everyone. People that are hard of hearing can turn down the background music that might get in the way of the speech, and other related approaches like that. But to get there, there's a lot of challenges in the way. This is not a very easy thing to do. So to produce this sort of content, you need to have a broadcast infrastructure that allows you to produce and distribute metadata. And our production systems are currently set up purely to deliver, or the radio production systems are set up purely to deliver a stream of audio and very little else. There's some stuff we bolt on the side, but essentially that's what it does. And we also need the tools to generate that metadata, either through capturing metadata that already exists, or providing extra tooling to allow the producers to create that metadata for their program. To distribute this, we need to be able to get different systems to talk to each other, so we need some level of metadata interchange, agreeing on endpoints so that things don't get mangled in the broadcast system. And we need an efficient way to emit this and code it up so that we're not quadrupling or increasing by 10 times the amount of stuff we have to broadcast. Finally, to actually listen to it, you need a renderer, so we need some tools to be able to do that. And you also need, it's desirable to have some level of consistency between the tools that are used to produce the content and the tools that the audience use to listen to it. So that is something we're very interested in R&D, so we're pushing for standards such as the EBU ADM renderer. So to be able to try and overcome some of these challenges, we decided the best way to do that is through practice. So we put together an object-based radio program that was both interactive and immersive. And it was an end-to-end object-based production, so it was designed as an object-based production and is kind of natively object-based throughout the whole chain. As I mentioned earlier, we did this twice in a way. We firstly did a pre-produced version because radio drama is traditionally recorded in a digital audio workstation. And then we unpicked that so we could do a live version as well, because as Simon mentioned, 80% of the radio is live, so we can't just ignore that 80%. We need to be able to have a broadcast chain that tolerates that situation. We delivered this through the web, so it was very easy to access, and we tested it through a platform called BBC Taster, which is a place where the BBC puts lots of experimental programs for the public to try out. So in this drama, there are 3 characters, and they move around 5 different rooms, and this is a drawing of where the characters go throughout the drama. So the time goes from left to right, and this character, Leslie, goes from the living room to the kitchen and back, and then goes to the bedroom and then back to the kitchen. And the idea is you follow one of these characters through their journey, and you hear different things depending on which character you follow, and you have a different perspective on the story. So that's one aspect. Another thing is that the drama is immersive, so we're using mono point sources and panning them, so we can render for binaural output, we can render for stereo and surrounds all through the web browser. And finally, we're also triggering some images to appear at certain times throughout the drama, which helps the listener understand where the characters are and what room they're in, and that sort of thing. So let's have a quick listen to it. Get this up. Let's hope this works. So we'll start listening to Leslie. She'll go off in the kitchen and start having thoughts inside her head, and I'll bring you back to the conversation in the living room.
So you're saying the mermaid made her drink a glass of water?
No, she's not saying that. I think we need to take a bit of a pause, a bit of a rewind. What do you think, Leslie? And what's more, I think a cup of tea would be the thing, wouldn't it? Yeah?
I'll get it. Don't move. The youngest was the prettiest of them all. Her skin was as clear and delicate as a rose leaf, and her eyes as blue as the deepest sea. But like all the others, she had no feet.
Shock. A kid collapsing in the hospital, all that.
Unless Mum put her there.
Unless?
Munchausen by proxy. Sick kid, sad mummy, centre of attention.
The large amber windows were open, and the fish swam in. Just as the swallows fly into our houses when we open the windows. Except that the fishes swam up to the princesses, ate out of their hands, and allowed themselves to be stroked. Yeah. Oh.
Shall I get a cloth?
How do I get back? Cool, so there's a quick sample, and I'll give you a link at the end of the presentation so you can listen to the full thing yourself at home should you wish. So we put this on a website called BBC Taster. It was up there for 3 months, which is the standard time for one of these pilots. During the 3 months, we had over 1,000 listeners, and over 115 people filled out a short questionnaire to try and gather some information about what they thought. So we asked them to give us a star rating, which is a standard thing to do with one of these pilots, and nearly 50% thought it was a 5-star experience, which is great. Some people thought it wasn't so great, but we did have some problems with iOS and it not working on Apple devices, so that could cause some of those people to become disgruntled. We asked them which feature did they enjoy the most. Switching characters turned out to be the favorite, but the immersive sound aspect was also very popular. The illustrations that went alongside it weren't anyone's favorite feature, but they probably helped. With having 3 parallel stories, we were interested in whether having these 3 stories, people felt like they were missing out on the other ones. So we asked people whether they thought having the choice of storylines made it a richer experience or incomplete. But 3 times the amount said richer compared to incomplete. We asked how many times people listened, and found that over 1/3 of people went back and listened twice, which is very encouraging. It shows you can get more value out of these sort of things. We asked, should we do more stuff like this? And nearly 90% said yes, so that's extremely encouraging. And it was nice to see that result. So I'm going to talk a bit about how we produced the program. There were two main teams involved. The production team, which looked after the editorial aspects and the script and the recording of the sounds. And then there's the technology team, which I led, which did all the building of the tools we needed to do this and the distribution and that sort of thing. We had a fairly standard team, a director, a writer, a sound designer. One of the roles that we added to this was a graphic designer to do the images. We also had to hire a front-end web developer to build the user interface so people could interact with this. And that's an important thing to think about with these object-based experiences. You do need a front end. And in many cases, that will be a custom thing that needs to be built for the program. But maybe there are some common elements we can standardize. So we had a script written especially for this by an Irish writer called Melissa Murray, who's very experienced in writing radio dramas, but not so experienced in writing radio dramas with multiple parallel threads. So this is a very challenging experience for her. Even just putting together the scripts, where do you put these parallel threads? So the script's a bit hard to read because it jumped around a bit. If I was to do it again, I'd probably get a team of writers and start to put together different ideas and do it that way. There was very little kind of interaction with the writer during this process, so I felt maybe we could do a bit better next time. There's a lot of planning involved to turn this kind of pre-produced drama into a live program. What we did is we recorded it in Pro Tools as standards, and then we extracted lots of different audio objects to play out as part of that live production. Here's a picture of our whiteboards. One of the limitations we set ourselves was limiting it to 15 simultaneous audio objects at any one time. Because we don't have infinite bandwidth, we need to be able to restrict it somehow to broadcast this thing. So we had to plan out when or which audio objects will play at different times and which channels they're going to be on. Hopefully in the future we can automate this sort of process where you can just chuck in as many audio objects as you want, and this pre-production stage, as we talk about, works out how to efficiently get that smaller. So we did a live broadcast of this drama in early July last year. It was a very different experience for the producers and for the actors. Even though radio drama originally was done live, they got out of the habit, so it's all pre-produced these days. So it was an interesting challenge in itself. There were some technical issues, things didn't go very well in the day, so we couldn't actually play out the sound effects. But we did demonstrate that working end-to-end object-based broadcast chain, which was our ultimate aim to do that. So we developed a lot of technology to be able to do this. One of the things we did was built a object-based radio studio in Broadcasting House in London. This is a picture of it. So we have some speakers on the roof, which you might find unusual in a radio studio. So we had 4 on the ceiling and 7 around. We used an entirely IP-based infrastructure and built tools on top of that to make it entirely object-based as well. Here are the challenges I showed you earlier. So we needed to come up with solutions for each of these challenges. So for the broadcast infrastructure, we used a system called IP Studio, which I'll talk about more in a sec. We used AA67 to move around the audio, and we used NMOS, which is the Network Media Open Specifications, for things like identity and timing and discovery. To generate the metadata, we developed a custom audio control interface, which I'll show you. For handling the metadata, we used the audio definition model, and we used a draft version of the serialized ADM to stream the ADM metadata. We used AAC to encode the audio and MPEG- to transport that over the internet. To receive the audio and metadata, we used what we call the BBC Audio Toolkit, which is a set of tools in the JavaScript library, which will soon be released. I'll talk a bit more about that. And we used what then became the EBU ADM renderer to listen to this thing in the studio. So I'll talk a bit more about these 3 things because they probably won't be covered in the other talks. So the first is IP Studio. So this is a BBC research platform for IP-based production. So it's not a product we're trying to build and release. It's a test platform where we can try out ideas and develop standards by doing experimental productions. It runs on commodity hardware, so it runs on any standard PC. We use open standards as much as possible, so we use AES67 for the audio transport, the networked media open specifications for identity, timing, and discovery, so that if you plug in a device, it goes, hey guys, my name's this, I do this, and we're going to base ourselves off this clock. So everything's talking to each other and knows what everything else does. This platform implements a plugin system for media processing, so we can connect to an AES67 stream, do some rendering, and then spit it out to a sound card to listen to it. For example, we can do AAC encoding, and we also implemented MPEG-H encoding and decoding later on. We have what we call a sequence store for doing storage, playback, and it also generates dash streams, which makes it very easy to broadcast. And we use this system to develop and test new standards primarily. Again, it's not a thing we're trying to release. So this is kind of one of the main bits of work we did as part of this, is developing an audio control interface. So this is essentially a mixing desk, but it doesn't actually do any mixing. What it does is act as a remote control to the listener's device, so that you're controlling the mixer on their device. And what it does, it generates a stream of metadata describing how you combine a number of audio sources for different experiences. It integrates with the IP Studio through NMOS. It controls the gain of audio objects, the 3D panning. You can add labels, you can group audio objects together, and it also includes metering, so you can check levels are correct. We support a level of interactivity, so we can say this object and that object should never be played at the same time, so they're mutually exclusive, for instance. And we also supported event triggering, excuse me. So this is where you send an event saying do something, and we use that to trigger the images to appear at different times. So I'll give you a quick glimpse into our setup for the Mermaid's Tears. So there's 3 tabs here, one for microphones, one for rooms, and one for characters. So here are our audio sources. So we've got some microphones hooked up. We've prepared some things to play out, so we can play a kettle sound, which triggers that. We can control the panning and the elevation, control the gain, and we can go in and change settings like the labels and colors and which devices they're hooked up to in the system. And so what we do is we take all these audio sources and we group them into rooms. So we have a living room, kitchen, bathroom, and bedroom. And then on top of that, we have our characters, and we can then connect these to the different rooms. So currently everyone's in the living room. Maybe Leslie goes to the kitchen, so we press kitchen, and that then switches the output of the Leslie character to the kitchen. If you prefer graphs, this is what it looks like. So we've got the audio sources at the top, which go into these faders, essentially. Then we have our rooms, and at the very bottom, we've got our characters, which are the 3 different outputs for the drama. So the final piece of the puzzle is the rendering, and this happened in the browser, natively using the Web Audio API. And so we created a library to do this called the BBC Audio Toolkit, which extends this Web Audio API and allows us to do VBAP rendering for speaker outputs and binaural rendering for headphone outputs. It also includes support for MPEG-Dash, so we can stream using Dash, and it includes support for a serialized ADM, so we can decode that metadata, know what to do with it, and know how to apply that to the audio signals. We are hoping to release this very soon, in the coming months. We're currently going through the legal process for giving this to everyone, but that's certainly our ambition. So hopefully we should be able to hand this over to you to use for your productions. So to summarize, object-based audio opens up a lot of new audience experiences, allows us to provide immersive, personalized, interactive and accessible experiences. We demonstrated how you can do a live, end-to-end, object-based production. So it is possible, and when we tested it with a load of listeners. They responded very well, like the interactive elements, like the immersive elements. There are lots of emerging tools and standards for doing this sort of thing, but at the same time, we did need to develop a lot of our own tools to be able to implement this. And finally, we published everything. So there's a ton of stuff we've written, which is on our websites. So please look at it. You are able to do this as well by reading about how we did it. Thank you very much. If you want to listen to it, this is the URL here. So take a photo or something. I forgot to print out handouts. But you can just go to this address on any modern web browser like Chrome or Firefox, and it should just work. Trademark.
As if by magic.
Yep.
Guys, do you have any questions for Chris? Fantastic.
Hello, Alessandro Travaglini from the Telos Alliance. One of the most important aspects in sound mixing and in drama sound mixing is voice reverberation and voice effects in general. When you have the user being allowed to change between characters, you end up into a situation where, depending on the main voice, on the character that has been selected, and eventually on the level and of the position of this source, the reverberation should ideally react accordingly. So has this aspect been considered in your experiment, and how has that been solved?
So for this experiment, we made our lives easy and didn't use reverb. But we have considered it. Our partners at Earcam have written an amazing report on object-based reverberation and different approaches you can take to use that to include reverberation whilst also dealing with interactivity. Because obviously if you take out a voice and the reverb tail is still there, it's going to sound pretty weird. But there are ways around that, and yes, we've definitely considered it, and please read deliverable something. One of the deliverables on reverb.
Thank you.
Any other questions? Got one up the back, and then Florian, if it's just one.
Hi. What proportion of the BBC's radio dramas do you see taking this approach in the future, and on what timescale?
In terms of parallel streams,
Yeah.
Probably very few, if I'm honest. We're attempting here to demonstrate what's possible rather than what we think should be the norm in the future. And this is just one idea. I think if we create a set of tools that are very accessible to producers, I think they'll come up with much better ideas than this and things we haven't even thought about yet. So we're really only trying to scratch the surface of what is possible rather than what is a good idea to broadcast all the time. It's mainly about creating the flexibility for producers to do this sort of thing, but not necessarily this specifically.
I think it's an interesting thing as well, and I think we have a sense that our creative and production colleagues are probably about 18 months to 2 years behind us on this journey. So they're starting out, and it'll be interesting as they start to understand what this is capable of, what they can achieve. Our director of the BBC Director of Radio at Radio Days Europe earlier this year kind of laid out an idea about trying to reinvent radio, particularly for the BBC networks, but also as a journey for the industry. So it would be interesting as people become familiar with this. I'm sure they'll find applications and audience benefits that yet we don't know about. So it's a bit of a journey. Florian.
Yeah, thank you. Just a quick one. What is the provision for synchronization between metadata streams and the actual audio in the system? Because it's, especially as far as dynamic metadata is concerned, certainly crucial that the timing is tight and is taken care of.
Yeah, so we're using PTP both for the audio and the metadata.
Okay.
And then at the boundary of that turning into a dash stream, we converted the timestamps into the dash timestamps. Okay. That's as much as I know without referring to my colleagues.
But I think we can safely say that timing in these environments is really, really easy, and you don't need to think about it at all. It just works. or maybe not. Thank you, Chris.
Okay.
We have another break now for you to go and grab a coffee, do some networking. I expect you to complete the full set of demos, so lots more hands up when you come back. You've got 40 minutes. If you can be back at 3 for the last session, that would be great. Thank you very much, everyone.